Today we're going to talk about basic nuclear structure and what actually makes up the atom. So atoms contain two general regions, if you will. One region is the nucleus, which has nucleons in it, and that's another word for nuclear particles. Two particles that are found inside of the nucleus are protons and neutrons. And then outside of the nucleus, we have our electrons. Electrons are a little more difficult to understand than protons and neutrons. There's a little bit more, they're more mobile, they're smaller, they're in a kind of a larger area, so we'll talk about them a little bit more separately. Some definitions for you. Nucleons, again, mean nuclear particles, or particles within the nucleus, and those include protons and neutrons. The AMU is the atomic mass unit, and this is based on carbon-12. There's actually a note on the little key on your periodic table that kind of reminds you of this. One more definition that isn't up here that is important, I'll be using this word a lot. Subatomic particles mean protons, neutrons, and electrons. So any of the particles that we find within the nucleus, or I'm sorry, within the atom are called subatomic particles. So starting with the nucleus, specifically the protons, the mass of a proton is 1 atomic mass unit. Protons have a charge of +1. They are located in the nucleus. They're what we call the identifying number. If we go to the periodic table, the number of protons is actually the atomic numbers. Those two numbers mean the same thing, and therefore identify the element. 6 protons automatically means carbon. 19 protons automatically means potassium. So those atomic numbers that identify the elements are giving you the number of protons. Neutrons also have mass of 1 AMU. A lot of students are like, that's kind of weird. Their masses do have very small decimal place differences, but for our purposes, we just round that to 1. They're actually extremely close in mass, almost identical. They have a charge of 0. They are neutral. They are also located inside of the nucleus. If you want to determine the number of neutrons from the periodic table, this is actually not so straightforward. You actually have to take the mass of an atom and subtract its protons. So that is something we'll tackle a little bit separately. What's special about the number of neutrons in an atom is that this can be different for atoms of the same element. For example, carbon-14 versus carbon-12. I talk about this example a lot because you've heard of it before. Both of these have 6 protons. This guy's going to have 8 neutrons, whereas this guy only has 6 neutrons. So everybody's got a job. If you're a proton, your job is being positive. By being positive, you can attract electrons. You help hold the atom together. The job of a neutron is being neutral. The neutron is actually able to kind of buffer some of the positive charge between all the protons and prevent some of that repulsion. There's a little more to it than that, but that's essentially its job. In an atom overall, what's important to understand about an atom overall has a neutral charge. But sometimes we talk about this term nuclear charge that actually helps us understand some of the things that are going on inside of an atom that we'll talk about more later in the year. But this concept's kind of nice to address now. Nuclear charge is the charge of just the nucleus itself, not the entire atom. So because the nucleus has only protons and neutrons in it, the overall charge of the nucleus is going to be positive. And the neutrons don't count toward us. So if we look at this picture right here, we have 3 neutrons. They don't have any charge, they're neutrons, they're neutral. Then we have 3 protons. protons. So the total charge of this nucleus is positive 3. Now, if this were a picture of an atom, in an atom, remember, protons are always going to be equal to electrons. So since we have 3 protons in the nucleus, we have 3 electrons outside. The overall charge for the atom is neutral. So again, the reason for this is kind of important to understand is that the nuclear charge is only talking about what's in the nucleus. Neutrons are neutral, protons are positive, so it's just really talking about the number of protons. So this is the charge again. Fix that a little bit. Of just the nucleus. The atomic charge is always equal to 0 or neutral. The nuclear charge is equal to the number of protons, and it's always positive because it counts protons and neutrons, which have no charge. It doesn't include electrons because they are outside of the nucleus.